welcome everybody, first of all. So as Baz introduced me, my name is Mauro Servienti. As you may guess from my accent, I'm Italian. And welcome to the State Machine. As someone already guessed, it's a Pink Floyd citation. So in about 1987, 1988, I was really, really young. And my mom would say also a bit stupid, but let's stick with the facts. I was really, really young. And with friends, we were used to go to concerts in small clubs, because small clubs back then in Milan allowed us to stage dive. So our main goal was not really to go to a concert to listen to a band playing music, but to basically stage dive. And that night, there was Red Hot Chili Peppers playing, but they were still not so famous as they have been a couple of years later. So it was a fun night, and we stage dive a lot. So nowadays, it would be awesome to be able to stage dive from this stage, but given my age, I'm 47 right now. It's not really a clever thing to do. So back to the future now. In order to be able to go to a concert nowadays and stage dive, the only thing that from a user perspective, or if you want to put it another way, from a customer perspective, you want to be able to do is basically buy tickets. So what you can do is go to a website and just buy a ticket or multiple tickets for a concert and then attend the concert at the venue. And obviously, stage dive. But that's not the important stuff we're not talking about. There's obviously a very different point of view in buying tickets. That is the act of selling tickets. Because all what they want to do is to make money out of selling tickets. They don't really care if I'm going to stage dive or not. That's not the problem they want to solve. And we can summarize all the operations, and in order also to keep it simple, all the operations they have to do in order to sell tickets to a very few key operations. The first one is display available tickets. So I have to be able to go to a website and list the available tickets for a concert or for multiple events. The second thing is to allow me as a customer to reserve tickets. The third one is obviously charge my credit card, because they want to make money. That's their ultimate goal. That's it. And finally, ship tickets. In doing all this stuff, sometimes the order matters, sometimes doesn't. And let me give you a couple of samples. It was probably 4 years ago, or 5 years ago. I went to an online shop of a really, really famous company, buying their newly released, just released tablet. And I select it, add it to the shopping cart, and select the shipment options, input my credit card details, and say, OK, checkout. Everything went fine. I got an email saying, OK, you're all set. As soon as the order will be shipped, we're going to charge your credit card. So the credit card wasn't charged at the moment of the checkout, but will be charged at shipping time. A couple of days later, I received an email. Hey, you remember us? We shipped your tablet. And 5 seconds later, I received a text message from the credit card provider saying, transaction denied. Oops. I was pretty sure that that email was basically eventually consistent. The email went out, but the order wasn't shipped. The day after, the delivery courier showed up with my tablet. And I went on receiving text messages by the credit card provider saying, transaction denied. So they basically tried to charge my credit card, failing while the order was already shipped. In that case, order matters. So the sequence of events. The interesting thing was that, that's just a little detour from the main topic, is that I also phone called them. So I called the customer service saying, hey, here is the situation. And the lady on the other side of the line told me, you know what? I know that. I see that your order was shipped and you didn't pay. But you know what? Our CRM doesn't allow that scenario. So your order is now locked as shipped and delivered. So enjoy your tablet. There's nothing we can do about it. And I say, yes, yes. Another interesting sample, very similar to this, in which the order doesn't really matter, are Italian motorways. So in Italy, motorways are paid. So whenever you enter the gate, you get a ticket. As you get out, you insert the ticket into the machine, and for example, you put in your credit card. What they do is they don't try to charge your credit card synchronously to you exiting from the gate, because if there's any problem, the risk of queuing up too many cars is so high, and the amount of money is so little, that they prefer to delay the charging of your credit card and incur into the risk of saying, well, someone might not pay. But for €2 across millions of customers a day, that's not really a big problem. So the order sometimes really depends on the context you're in. But it's important to realize that sometimes it's important. So if we want to, going back to our tickets buying scenario, so we can try to think about buying tickets and implementing that in a naive way. So all the code samples are C#-like based. It doesn't compile, but it should give you the idea of how it works. So the first thing that we want to do is basically being able to display available tickets. So we do some call somewhere that returns a list of tickets, of seats, available seats. The second operation we want to do is select some seats. So out of the available seats, I just take 2 of them. The third operation is to be able to reserve those seats. So I'm telling the system, I want these 2 seats. The third is try to authorize the user credit card. So the credit card payment is usually 2 operations. The first one is the authorization, and then if the authorization succeeds, then the credit card is charged. So what we do is basically authorize the credit card for a specific reservation, and if, and only if, the reservation succeeds, then what we do is charge the credit card and ship the tickets. These 3 operations, and probably also the first one, but that's not really important for the use case, but at least these 3 operations are for sure remote operations. So we're talking to remote systems. So we're talking to the credit card provider and the shipping courier provider. So if the first one fails, that's not really a big deal. So even if we're not able to roll back the reserve operation, we'll live with 2 tickets reserved for a while. And maybe there's a batch job that overnight frees up tickets that are not paid. But at least there are really no problems from the system perspective. So the first one can fail. Everything is rolled back in quotes, and we're fine. But the other 2 must be coordinated in some way. Because if the charge operation succeeds, but the shipping one fails, then we're left with a user that paid something that won't ever receive. And we cannot really start again from the beginning, because this procedural code will reserve 2 more tickets, will charge the user once again, and ship 2 more tickets. So the user will end up paying twice, and instead of receiving 4 tickets that they don't want anyway, they will receive just 2 tickets. So that's not the thing that we want. And we cannot even swap the 2 operations and say, OK, let's try shipping first and then charging the card, because otherwise we'll end up in the tablet scenario. We'll ship something that will never be paid. And being remote requests, we have those horrible scenarios where HTTP, that is an amazing protocol, by the way, we're sending out an HTTP request that succeeds, but we'll never receive the reply. So the credit card is charged, but we don't know that. And now what do we do? Shall we ship or not? That's a huge problem. Usually, the first approach to solve this problem is through a process manager. That's the typical domain-driven design approach. So I won't get into the details of what a process manager is. It's not the topic of this talk. But I'll try to highlight how a process implemented using a process manager kind of thing could look like. So we have the ticket selection step, okay, that talks to the reservation system and asks to, okay, reserve these 2 tickets for me. And then publishes an event that is order checked out. So the user basically hit the button saying, I want these tickets. At which point, an orders manager kicks in, saying, OK, I can handle this order checked out request. And the first thing that they do is authorize the credit card through an anti-corruption layer that acts like a gateway between our system and the credit card provider. Once I receive a reply back from that anti-corruption layer, what I can do is saying, OK, reservation, I'm done. I've authorized the card. So we can consider those tickets as sold. Okay? We want to get into the details that we are authorizing a card 1 minute before midnight. Right? That's a huge problem, but too complex for this scenario. Then we go back to the credit card anti-corruption layer saying, OK, charge the card now. Because we're all set. We know that the tickets are reserved and that you can pay them. If the charging succeeds, then we can ship tickets. Again, those 3 operations are remote requests, but we can decouple them from the process manager through messages. In fact, I use those little 3 envelopes to identify that those operations are basically decoupled through a messaging system due to the fact that they are remote requests. What I'm doing is basically saying I'm isolating into another process something that cannot be included into the logical or physical transaction inside the orders manager. So I'm starting from the assumption that the reservation system lives in our system, maybe in our database. Okay? So we can have a distributed transaction with that or some sort of transactional environment, but we cannot really have a transaction with a credit card provider. That's why we are trying to decouple ourselves as a process manager from those 2 actors. The problematic thing is that we still need some sort of orchestration between these 2. And that orchestration will live within the process manager boundaries. Because that's the only place where we know if the credit card charge operation succeeded and we can ship. And if the shipment failed, we need to be able to roll back something else. So the thing is that this kind of orchestration is not really the only issue that we are facing when you introduce a process manager like this one into our system to manage this kind of long-running business process. So the process manager introduces something that can be seen as another kind of issue. The process manager owns the entire process, but also owns the entire set of data related to that process. So if we can look at that kind of process manager from a different point of view, that is the database point of view. Imagine a table schema for that kind of process manager, and we'll basically have a table like this one, where we have a primary key, order ID, shipping status, payment ID, payment status, payment type, and all these kind of columns. And for every single order, every single order is represented by a row in this table. Now someone from the business comes in and say, you know what? We want to be able to allow customers to collect the tickets at the venue. Oops. What does it mean? That shipping doesn't exist anymore. So whenever a customer says, I want to collect my tickets at the venue, so I don't want them to be shipped at my address, that means that ShipEgg ID is basically null. So that kind of new requirement is a disruption from the schema perspective. Because first of all, what we need to do is to change that column to be from not nullable to nullable. And that's already a problem. The second thing that we need to do, given that now we have this dichotomy between the code and the table schema, we need also to introduce a third column that explains why the first column, shipping ID, is null. Because otherwise, from the code perspective, we load some data, shipping is null, and why shipping is null? Is null because we haven't shipped yet, or because the shipment doesn't exist because it will be collected at the venue. So we need to evolve the entire table schema. That is a breaking change from the process manager perspective in order to accommodate this new requirement. Basically, taking it to the extreme, we can say that the process manager is very much like a punch card, where my collect at the venue business requirement should fit into there. The only option to achieve that with the punch card is to throw away the punch card and start from scratch. It's not really what happens with the process manager in our code, but you can imagine that a new business requirement can come in and be disruptive from your code base that is already handling a complex business process. And in a complex business system, it's very easy to end up with a punch card that looks like this, where we have our tickets sitting in the middle, and then all the services, or all the aggregates, or all the bounded contexts, or all the microservices, call them as you like, trying to deal with that ticket. And by the way, there's customer care down there, because we're Italian and customers doesn't really matter. So. And all these services trying to deal with the single ticket that we're trying to ship or to pay or to whatever. And then we have those three people standing in the back where they are the orchestrator and the failover. Because as soon as we have an orchestrator, or in the Windows Microsoft Word, the distributed transaction coordinator, looking at a long-running business process going on, we need also a couple of failover machines. Because otherwise, if the orchestrator fails, everything fails. And we don't want that. So taking it to the extreme, we can say that the process manager is a kind of a fragile type of pattern. And it's a kind of fragile because it violates the single responsibility principle. So it's doing way too many things. Because the orders manager, or the tickets ordering manager in this case, is dealing with payment, shipping, reservation. All the process is coded inside a single class or a single manager. It's a single unit of deployment. Now, every single time we change a little bit of that code, we need to deploy the entire thing to production in order to be able to ship the new feature to production. It can be a source of conflicting changes and merge conflicts. Because if we have multiple teams, one that is dealing with the reservations, one that is dealing with shipping, one that is dealing with payments, they are all looking at the same code base. They are all of them are touching the same repository, meaning that whenever they touch something, that change can be conflicting with someone else's change. And could be also a source of contention and performance issues. Because obviously, the entire process is managed in one single place. So if we end up realizing that, we need to scale out the shipping part, we cannot really. We need to scale out the entire process manager. The reality is that there's no spoon. So there isn't really the process manager. So if we think about it, it's very easy to be tricked into the process manager kind of mindset, because the domain expert talks about the ordering management, the tickets ordering process. So the business talks about this kind of process. And it's very easy to, especially as engineers, to, as soon as they start talking, in our mind there will be a public class order manager with public property, paid, Boolean, and stuff like that as they talk. And it's very easy to transition from something they talk about from the business point of view to something that is code. Our end goal in reality is to look at the business process, chop it up into multiple components that being autonomous can collaborate with each other into this collaborative domain. So all the things that we've talked about so far, reservation, payment, shipping, insurance, there might be many, many services or many, many contexts involved into the process of buying a ticket, should really be completely autonomous and should be able to collaborate with each other in order to achieve the end goal, that is, make money by selling tickets. They should not be monolithic in order to be able to sell tickets. This is when Sagas come into play in order to be able to deal with collaborative domains. So we have a complex business domain that is the act of selling tickets, and we want to be able to deal with that. What are Sagas? The simplest definition I've found online is this one. So it's multiple workflows, each providing compensating actions for every step of the workflow where it can fail. Let's analyze that, sentence by sentence. Multiple workflows. So what this definition is telling us is that there shouldn't be one single workflow dealing with the act of selling tickets. There should be more than one. So can we identify in what we have seen so far those workflows or those services or boundaries that own the workflows? It's quite easy, you know? So we have these three main operations: the act of reserving tickets, the act of charging my credit card, and the act of shipping tickets. So we can move those to reservation, finance, and shipping as boundaries or as services, call them as you like. And those three boundaries are the three main boundaries involved into the act of selling tickets. So we can now define the entire process of selling tickets using multiple workflows. So the first action that we do is list available tickets. Selecting those tickets will be done against the reservation. Then we go to some sort of shopping cart page where we have the selected tickets, and we proceed to checkout. Once we proceed to checkout, reservation does its job, doesn't really matter what it is right now, and publishes a reservation checked out event that is interesting from finance. And finance does its job, probably authorizing my credit card, and publishes the payment authorized event. That is interesting again from the reservation point of view, that now can say, okay, we're done, so the order is created. That is interesting from finance perspective, that can say, yep, payment succeeded. Those two last events will be used by shipping to say, I can ship now. So if shipping receives the order created event alone without never receiving the payment succeeded event or the other way around, it won't ship. There's no way that shipping will ship something that is not paid. Okay? Those are the three workflows now. So we have a workflow related to the payment in finance. We have a workflow related to the reservation process in reservation. And we probably have a workflow inside shipping related to how we ship. Okay? The entire process is the tickets ordering saga. So the saga is the result of the collaboration between these three different workflows. In particular software, we prefer to call them policies. And workflow is not really a business term. If you go to a business stakeholder saying, we have a workflow, they don't really understand what we're talking about. So the shipping policy is something that sounds much more interesting from their perspective. Okay? And by the way, if you've been to the event storming masterclass by Alberto, those are pivotal events. So those are the so-called pub/sub events or public events or notification events or pivotal events. Events is such an overloaded word, but by the way, those are the four main events that causes the entire system to transition into a new state. As you can imagine, there might be much more events inside each workflow, but they're not interesting from the outside perspective. No one cares. So these are the only four important events from the outside. Should we open the black box now? So should we look inside every single workflow? Yes. So again, available tickets, ticket selection, and shopping cart, proceed to checkout, reservation, check it out. There isn't really nothing important in the reservation, even if there can be many, many different workflows in there. Finance reacts to that. The first thing that finance does is go to the payment gateway to authorize the car. Once the authorization is received, payment approved, or authorized, sorry, reservation reacts to that, order created. Finance again is interested into that, charges the credit card, and we're back to the final state. That is, shipping reacts to both and ships. And shipping talks, sorry, to the gateway that talks to the delivery courier in order to be able to ship. Is it more complex than the naive approach? Sounds like it is. So, but in reality, the naive approach or the process manager are hiding away the complexity of the business process that is much more highlighted by the way we designed it. And it's way simpler to understand the complexity in the way we designed it right now than the way we designed it before. So even if it's more complex, it's simply highlighting the complexity. We're not making it more complex. We're highlighting something that was hidden before. So let's go back to the new requirement we talked about before, collecting tickets at the venue. The first thing is that now the tickets collection is segregated there. So we can hide away all the rest of the process and concentrate on the shipping policy, because it's there that we're going to apply changes in order to be able to ship to the venue or ship at my address. Okay? So let's look inside shipping now. So shipping is triggered by receiving these two events: order checked out, or order created, sorry, and payment succeeded. So what now shipping can do is basically say, well, I change myself so that my state takes into account the delivery mode. That can be collect at the venue or ship at home, whatever. Doesn't really matter in this case. Whenever I receive those two events, I look at my state and say, what was the selection the user made during the checkout process on the website? Do they selected collect at the venue? If the answer is no, they go on proceeding as before. They deliver tickets, talking to the delivery courier, and we're set. The answer is yes. They store the ticket for a later delivery that is probably another policy. So now we need something that is capable of collecting batch of deliveries, because we're selling tickets that should be delivered all at once to the venue at a specific point in time. So what we're doing internally to shipping, we're basically listening to that store for venue delivery message and saying, okay, someone wants to deliver 3 tickets to that venue. Okay, I'm storing. 3 days before the event, I'll ship them all. And I'm fine. That means that as soon as we send out these 2 messages, deliver tickets or store for venue delivery, shipping is conceptually done. We don't need that state sitting in the middle anymore. Because from the shipping perspective, it's shipped or someone else will take care of that. That is the batch delivery. So now the batch delivery can kick in and say, okay, I'll ship to the venue 2 days before, the same day, doesn't really matter when. And that means that now the shipping at the policy venue once needs to talk to the delivery courier 2 days before, ask for shipment. When the delivery courier replies back, can say, okay, I'm done. But no one cares. So from the outside, no one cares about this part of the problem, of the process. So it's the entire set of changes that we are applied are inside the shipping black box, because shipping is fully autonomous now. Before, in order to be able to introduce that, this new business requirement, we should have changed the entire process manager. But the definition is a little bit more complex. So each providing compensating actions, meaning that if they are autonomous, they should be able to roll back, whatever rollback means in this context. Okay? So let's look at a scenario in which we can have a problem. So we have all our process there, and reservation fails. So when reservation receives the payment authorized event, kaboom, reservation dies, or those tickets are gone for whatever reason. So we cannot really publish the order created event. That means that finance won't ever receive that order created event, meaning that finance won't ever charge my credit card, meaning that it won't ever publish the payment succeeded event, meaning that shipping won't ever ship, because it will never receive the 2 events required to trigger the shipping policy. To some extent, it's nice. So if we have a failure in one of the components collaborating with each other in order to solve the business problem, we automatically interrupt the process. There's nothing we need to do. The problem is, oops, we authorize the card. So we're now locking money on the user credit card for no reasons. We have 2 options. Do what every single hotel does, that is, do nothing. At the end of the month, the credit card provider will roll back authorized transactions that are not charged. But that's not really fair to customer, or polite, at least. Or we can try to solve the problem. So what we want to be able to do is that finance can in some way react to the fact that reservation never published the order created event. So let's look inside finance for a second. The first question, or the temptation we might be called by is, let's go to reservation and ask them to create a reservation failed event for us. That's coupling. So whenever you have a service or a bounded context that needs to go to another context and say, hey, can you change your process to accommodate my needs? That's coupling. It's not code coupling. It's logical coupling, but it's coupling. So we're coupling them. So that could be a good sign that we need to go back to the whiteboard and ask ourselves, are we doing things right? But in this case, we don't really need that reservation failed event. And by the way, if we're using messages, reservation might have failed to publish the order created event because the reservation system was dead. So if that system was dead, there's no way to publish the reservation failed event either. So finance is still in this kind of no man's land saying, okay, what should I do now? Like John Travolta looking around saying, what can we do instead? Can we apply some sort of change inside finance only that is capable of reacting to something that didn't happen? And the answer is obviously yes. So we can change the payment policy to emit what we call a timeout, for example, for 48 hours, to release money. So what we're basically saying is, whenever we receive the reservation checked out, we authorize the card, publish the payment authorized event, and request a timeout. We'll see in a second what it means, requesting a timeout, for 48 hours. 48 hours later, the timeout comes in saying, hey, you asked me to call you back 48 hours ago. Fine. Finance can now ask itself, have we received the reservation, the order created event? Were tickets reserved? If the answer is no, we can go back to the card provider and say, okay, release money now. If the answer is yes, we do just nothing. Why? Because if the answer was yes, reservation would have published the order created event, meaning that finance would have charged the credit card through the payment gateway, published the payment succeeded event, and marked itself as done. So basically, by marking itself as done, it means that the state for that specific policy or workflow is not needed anymore because we're done with the payment for that reservation. So the timeout itself is basically ignored. So we're just handling the failure case because the successful case is automatically handled by the system. What's a timeout, by the way? So let's try to look at it from the code perspective. So we have a reservation checkout event coming in. So we have some sort of method that handles that message. It is a class that comes in. That the only thing that does is send a new authorization request. That authorization request goes to the payment gateway that handles the authorization request. And what it does is authorize the card and replies back with the authorization response for the authorization ID and says, now finance reacts to that saying, okay, publish the payment authorized event and request the timeout. So that request timeout is a message, a physical message, delayed in time. Most brokers can do that. So for example, RabbitMQ can do that. Azure Service Bus can do that. You can ask the broker to say, okay, send this message back to myself, but not immediately, but tomorrow at 5 p.m., whatever, or within 48 hours, or within 5 seconds. Doesn't really matter how long. So when the timeout comes in, we can ask, was it reserved? No. Then what we need to do is basically release the money through the credit card provider. Again, as we said before, we're isolating the act of talking to the credit card provider into its own process, the payment gateway, because that thing cannot be enlisted into the same transaction in finance. It needs to be isolated. On the other hand, these two operations are transactional. Depending on the broker you're using, might not be really transactional, but there are ways to make them transactional. So let's start from the assumption that there's basically no way that we publish an event and the request timeout fails so that we are in an inconsistent state. It's all or none. Okay? That's the assumption. So let's go back for a second to the database view, the database schema view. So we started from here, a single table handling the entire ordering process. As soon as we introduce Sagas, we switch from this kind of schema to this other kind of schema. So every single context now has its own tables, set of tables, or database, or whatever kind of storage they want. And they can introduce even polyglot persistence, but it doesn't really matter for the topic of the talk, where the only relationship between all these tables is the primary key. So it's a kind of virtual foreign key. There isn't really a foreign key across multiple storages. But we're basically starting from the assumption that the primary key is stable enough. Well, if it's not stable, we have much bigger problems. But a primary key is stable, so we can tell everyone involved into that business process, hey, the order ID is 123. Now do whatever you want with that key. Meaning that now each service can evolve independently. And shipping is the one that can changing the type of structure when they need to handle the collect at the venue delivery mode without affecting anyone else. And for example, think about, I don't know, you're selling online stuff like Amazon does. Suddenly someone comes in and say, hey, we want to allow digital downloads, meaning that there's no shipping at all, again. Or we want to allow wire transfers, money transferred instead of payment through credit card provider. That is not synchronous anymore. We have to wait for 7 days for money to come in, check in the bank account, see if the money is there, and then. So it means that we don't want to destroy or disrupt the entire process just to change something that should affect finance only or shipping only. So what's the benefits of Sagas over the process manager in this case? The business process is distributed. And given that the fact that the business process is distributed, we're respecting the single responsibility principle. So we're basically saying each single actor or workflow or service involved into that collaborative domain, can change independently and is responsible for a single kind of operation. We have a simpler, not conflicting evolution, because as you can imagine, now we can have a finance repository, a shipping repository, a customers repository, a tickets repository, a reservation repository, and all the teams involved into the development, they touch a single code base without affecting anyone else. And we have independent units of deployment as well. So if we change something in shipping, we just deploy shipping without disrupting production for anyone else. And finally, they are independently scaled out. So we can scale out one of them without being forced to scale out all of them. So another Pink Floyd citation, because last year the talk was 1 hour long. This year, 45 minutes long. Next year will be 30 minutes long. So every year is getting shorter. So for those of you using C#, there's a full demo of the entire process available at the first link. And the second link, there's Udidan talking about Sagas. So to conclude, last 3 minutes, let's have a look at a couple of pitfalls and a couple of takeaways. So one pitfall by moving from process managers to Sagas is obviously that the process is distributed, meaning that the state is distributed, meaning that monitoring the state of the process is way much more complex. With the process manager approach, if the business wants to know where are orders, you look in one single place. With the Sagas approach, if someone asks you, what's the status of this order? Hold on a second. You need to understand where the order is. Are we in the payment status, in the stage, or are we in the shipping stage? And then understand where to look at. So there's more complexity in monitoring the distributed state. So we can say that it needs to be worth it. We don't want to move from process managers to Sagas if it's not worth it. Be careful at doing the jump. Okay? Couple of takeaways. Behaviors define how to design processes. So basically, follow the coupling is the underlying rule. Do not look at processes in terms of data, but look at processes in terms of what changes what, and what needs to be changed together with what. So if we're changing the price of something, does it affect the description? If the answer is no, they should not stay together. If the answer is yes, they should stay together. So look at the processes, look at what they touch, and model your boundaries based on what they touch. And within a large business process, identify workflows or policies or subdomains, or there are multiple terms probably that apply to the process, and chop them up by service. So by identifying the autonomous components that needs to collaborate with each other, but should be really autonomous from the evolution perspective. And finally, use delayed messages to model time. That's one of the key aspects. So whenever you need, in an asynchronous system, whenever you need to take an asynchronous decision, you need to be able to set an alarm that when it goes off, forces you to look at the state and say, okay, what I was expecting to happen, did it really happen? No, so I should do something else. And finally, the most important thing is there is no such thing as orchestration. So orchestration is never really required. It's probably due to the result of someone talking about the manager, the process manager, the tickets ordering process. And we tend to design an orchestrator to align with the way the business talks, but it's not really needed. So my name was Mauro Servienti. There's a few details, and thank you very much.